A couple of days I posted a video about blobs and that I was able to render 1,000,000 blobs in a single scene, but I didn't really add any context to what it was because when you start explaining your game idea it all sounds very fantastic, but yesterday I was working on chemical dilution. And you guys know me, I don't have an official degree in ICT, so most of the things I come across and learn are kind of through experience. And what I'm trying to model is soft logic. I don't know what the word for it is, if there's actually a scientific word for it inside of ICT or science. But soft logic to me is where you, without directly instructing a particular NPC or creature to do something, you still get a particular behavior. And so soft modeling requires you to make very abstract systems that ideally aren't descriptive either. And so what does any of this mean, right? Like, what am I hinting at? Well, what I'm hinting at is that, as you can see right here, these creatures are all running a tiny neural network. And so the question is, how do you make these creatures see without hard-coding an eye, without telling the computer, go over a list of possible things in the world and do something with it? Well, the first step is obviously a neural network. That's obviously the first step. And so when you have a neural network, you now have the ability to give input, as long as it's a number, preferably a normalized number, to the creature, and it will have some response to it. Now, what response? It doesn't really matter because the brain is randomized. That means that the creature, if you give it the input, its position, and then you tell it to give two outputs, it will just do one thing and one thing only. And you can see that here. The creatures are just going in circles, and that's really it. Why are they going in circles? Well, that's just the mathematical result of processing with the given inputs to the brain, the hidden layers, and then the particular amount of outputs you want. So the only hard-coded feature here is that I tell the creature to have a particular direction to go to, and to accelerate or decelerate. So I have one hard-coded feature, but I started to get really bothered by this. I didn't want to make a creature understand where the position of food was. So how could I do this without hard-coding the position of food? And so I started thinking in terms of fields. Like, I don't know if I properly grasp what fields mean in science, but like fields are, you have a field, a grid, and each particular point in that grid has a number for whatever reason, and this has an effect of things inside of the field. And you could be more abstract. Some fields have an effect on other fields. So a field really is just a grid with numbers that does a certain thing. And so here you go. I made a chemical field because I was interested in having the creatures release chemicals into the environment and somehow have them use that as an input instead of their actual position in the world. And so now their behaviors are much more organic because the inputs are also dependent on where every other creature is. And so if I now make a field density and have that be something that affects the velocity of the creatures into a particular direction, I can model physics for creatures that get close together by saying this particular point in the field has high density, and so it pushes things away. And if it's low density, it pulls things in. And the thing is, when I started this project in the video, I only had positions for the creatures. And the optimizations I've been implementing the past couple days made sure that the world is fixed, right? It's no longer an infinite world. And then when you leave the top, you enter the bottom. It's like a toroidal world. And because of this, I can use textures to model these fields because every map is a fixed size. And the other optimization that made all of this work so well is that each creature is now 1 pixel. So now I have an atomic scale for which to simulate the world. Because one of the problems I had with metaball rendering was if the metaball is too big, you need to add it to multiple cells. But that is so, like the variation in size is very complicated. So now each creature is made of at least one cell, which is 1 pixel, which has 1 point in the field. And so now we've solved this issue where I can model the world entirely and the creatures respond to it. And so obviously when you grow the complexity of the game, you would make creatures with multiple cells. And since each cell has a particular response to particular fields, they get complicated behavior. Now the question is, will I make a centralized brain that just absorbs all of the information, or will I make it more like an octopus where every cell is responding differently, but because of like spring-based rigid body physics, they pull themselves a certain way. And the ones that somehow succeed at their random combination, those will survive. And so really, I have nailed down the hard-coded logic to basically certain fields I want, certain physical realities about the world, and at minimum an energy and reproduction requirement. So the blobs have a certain energy, the fields have an impact on it, and the blobs have an impact on the field. If they run out of energy, they die, and if they reproduce, they reproduce. So my hope is to find an abstract way to even represent the chemical interactions, such that the idea of energy is not a literal value anymore in the system. So then the only thing left is reproduction. But I don't think it's feasible to have those things be soft logic without modeling actual chemistry, which is how life evolved, and God knows how complicated that is. So to summarize the project, what I'm trying to do is get something like spore cell stage going on, but I wanted alien and real life, and I wanted to make a system that functions on its own and creates complex emergent behavior without coding any of it. Not because I'm too lazy, but because it's more interesting, right? So the creatures can evolve their own shapes based on some physics. I can add fields. These fields are just numbers. So like in a God simulator, you can just brush the numbers. You can create your own creatures. I don't really know how that's going to look, considering the cells right now have tiny neural networks which produce an output and take an input based on some properties. So how would you add the human element to it? I don't really know yet. But that's really the explanation of it. And since yesterday I had a functional field for the first time, I just wanted to really share the progress because I thought it was worth it.